Morning, everyone. I don't know, Vidar, if you want to wait another minute or we can open the webinar, maybe.
I think we're about ready just to get going.
And I have time to finish my coffee. That's perfect. Okay. Lovely. Marlene, you will share the screen or the first slide? Or?
Morning.
No?
As you want.
No, maybe I don't know if it's the last version of the document I have. Okay.
Should I start, Vidar or Rafael?
Please.
Yeah,
I have a few mention things on EuCIA. That's the reason. It's not related to the webinar. If you don't mind, it's just it's just 1-2 minutes about EuCIA and just to first of all to remind you to comply with the European competition laws and not to share any specific informations. And that's maybe you can put in full screen and okay, super. Go to the next slide. That's perfect. Okay. So that's which is not written here, but it's the first thing is to comply with the European competition laws. So we will have to moderate and to behave as all EuCIA meetings. You keep your microphone muted. For you will have the presentation and then you will have the time for the Q&A. So yeah. The microphone is muted is useful, so please do it. By participating, you consent to the recording and processing of data. I think someone has his microphone. Yeah, if you can switch off your microphone. Thank you. Next slide, please, Marine. It's just to tell you, so the European Composite Industry Association, if you don't know, we are the voice of the European industry, and we support all initiatives to redevelop a sustainable growth of our industry in a flourishing business environment. So that's why we have different activities through the years. And sometime with the European authorities on the right of your screen is just here the vision, and it took us some time to really in short graph to show the circularity of composite material. First, it's designed to last long, and for the bridges, it's even fantastic. And then, what are the solutions at the end of use of the material, and also the different options between closed loop and open loop. That's so here we summarize the circularity of composite material. Next slide. Very quick. So that's the different members of EuCIA. So we have national associations, like of course the Norwegian associations leading the webinar today. Also we have industry sectors with the resin manufacturers, textiles, SMC, BMC. Also the pultrusion industry, of course. We all together represent 85% of the European composite market, and it's based on the EuCIA market study. So we take all the different countries, and that's the weight. We have sponsors and Excel and AirTech, and we have a strong partnership with JVC. Last slide, I think. That's it's just to show you what are the different things here. It's part of the board of the board of EuCIA, interaction with our president to the European Commission, the working group sustainability. That's it. I think that's the last slide, right?
Yes.
Yeah, very good. Okay, so that was just the introduction, and welcome all of you. And then I leave the floor. I don't know who is taking the lead, if it's Stian or Vidar. So please go ahead. The time. the floor is yours, as we say. Okay.
Thank you very much. I will not talk much in the beginning. I will just say welcome to the webinar. Today is about bridges in composites. And the whole webinar is based on our experiences within this field in Norway. And I'm not going to say more than I want to introduce Stian Persson here, and he will do the first out of 4 quite short presentations. And then we will be happy to receive questions towards the end. So thank you.
Perfect. Thank you, Vidar. Do you see my screen?
Yes.
Yes?
Yes.
Yes, I assume so. Very good. Thank you. Okay, we don't have very much time. I will talk a little bit about composites and decision making in Norway, especially, and why we chose FRP as a material for the first county bridges that was the first to be handled by the Directorate of Public Roads and the approval process there, and to follow the handbooks. So I will use 2 bridges as background for explaining what we thought, and I will explain a little bit about why I am speaking about this. So more the key drivers to the material choice of these bridges. And then I will say a little bit about how we procured these bridges when we had decided the material. The bridge you see on my screen now is the very first FRP bridge that was built by the county in Norway, and also the very first bridge to follow the handbooks fully out, and also the first to be through that approval process. So this bridge really represents what is possible, but also it represents a lot of learning. I will move on. Just a little bit who we are. The company I'm representing, MSS, has a 20 years history of offshore solutions. And the last 6 years especially, we have really driven the focus on shore and on bridges. And by now we have delivered 12 bridges in Norway in FRP. And number 13 is actually in the detail engineering now and will be installed in June next year. So we're starting to get some experience here. We work as an agent in the Nordic countries, but we're also the owner of FiReCo Europe, which has delivered close to 2,000 bridges worldwide. So this is nothing new. I can mention that FiReCo is specialized in vacuum infusion, and they're using the InfraCore Inside technology. Just a little bit of my background, because what I'm going to start speaking about and the bridges I will mention is based on my previous experience as the client side, because I started out with 11 years in the Norwegian Public Roads Administration. And it was really there it all started back in 2014 when I was the head of the bridges section there. So the 2 bridges I will mention later is in the background of that. So that's why I just wanted to show you this background so you get that experience. So I also have experience from the consultant side, following up the bridges and supporting the client when it went over to the county, and now I'm the head of infrastructure in MSS. Okay, you probably have noticed Paradis pedestrian bridge, which is a world record and also one of the Innovation Award finalists in the JEC world. So I will just tell you a little bit about the timeline of this bridge, because it all started in 2014 when I was in the lead of the NPRA, where we started to look into a preliminary design and concept approval for a bridge in FRP. So this took a year. It's a big process. It was a lot to learn. And at that time, we hired in Royal Haskoning, and also we used consultancy Multiconsult to do everything around the bridge. In 2020, there was a big splitting of the bridge environment in Norway, where you splitted the responsibility between national and regional, county versus national. And then this bridge and the other bridge I showed on the first page went over to Vestland County. And in 2022, this was tendered as a design and construct process with interaction. I will explain a little bit more about that later. And it is just installed this year. So why did we choose FRP for this bridge in the first place? First of all, I want to show you the top picture here. We always start with concrete in Norway, especially in situ concrete. That is something we use a lot. Probably 90% of all bridges are like this. But in this case, we had height restrictions. We couldn't elevate the road, and also we had the light rail going below it. We also noticed that we weren't allowed to put any piers close to the railway. So this first concept, that was a no-go. Furthermore, we could not close the light rail for any more than 72 hours. And that's the same with the road next to it. And it comes with a huge cost. So it was also important to get low maintenance, because you don't want to close the light rail just to do maintenance on the bridge. So everything around this, we were quite quickly able to limit out concrete, steel, and wood. And what we saw was that FRP actually ticked all the boxes. So we decided this is a material we need to learn more about. So we sat down, we did decide we go for FRP. We got in Royal Haskoning, and together we made different design choices, and we did a popular vote at a session team of engineers and architects, and we decided on the concept. And it was very important in early stage to allow for assembly on site, because we didn't know if it was possible to produce everything at once, because this was a world record size. So that was one of the concepts, and it was important to have quick installation, like we mentioned, over the light rail. And we had to think about how can we get most producers to be able to do this, because we want competition, of course. And it turns out that the low material weight was a pretty good added bonus that actually allowed to build this complete structure in once and produce and freight and lift and install everything at once. So that was a great bonus. So also at the time, I mentioned we started looking into it in 2014 and 2015. We started looking into the concept design. At that time, we had a new handbook coming out, and this new handbook had a new demand in it. And this demand was that the underside and edges of any bridges spanning over railways, which included light rails, 4-lane highways, or roads with an annual daily traffic of 8,000 or more, the materials should be made out of materials that need no planned maintenance. So that kind of rules out, steel and wood and everything like that. So this was really the push we needed to go forward with something different. I think it's worth mentioning that from this year, we also have another edition in the rule book that says that any choice of bridge type and material has to be justified and optimized with regards to sustainability and emergency preparedness. And then we get the CO2 emissions and everything. It wasn't a point when we started, but now it is. And it turns out that FRP is actually half the CO2 emissions compared to concrete. So that's another added bonus. So we had solved all the restriction and bridge concepts. So how did we put this out in the market? That was, we had never done this before. So we knew that we wanted to test this out, but we also knew that going out with a world record for the first bridge, that's a bit risky. So we had another bridge that was half the span, around 24 meters, called Vardebrua, the first one I showed. We decided to divide substructure, the abutments, from the superstructure so that we can, get just the producers in and work together with them. So we decided to go for a design and a construct contract with negotiations because we knew we weren't able to nail it right away. And the substructure was done by the MPRA themselves then when I was there. The concept design was done in 2019. We also had Royal Haskoning with us at that time. It tendered in 20 and it opened now in 2022. So this was built by MSS and FiReCo. The good thing about this way of working is it was a very good collaboration when the client is running the overall pictures, because then the producer can do what they do the best and the client do what they do the best. So you can procure an FRP producer directly. What we see is it has to be a very defined project and the risk has to be low or else the price will increase a lot. Also, it took a little bit longer than we thought it would, so the abutments were actually finished before we were able to do all the detailed design on the superstructure. And of course, that's not ideal. You can't get the optimizations you want. And also, it's definitely not the ideal way of tendering when it's a first ever to go through a new process, because it takes time. And of course, a design construct contract like this is a fixed price contract. So that was a big issue. So what we learned from that process is that we needed an extra, let's say, process in here to be able to reduce that risk. So for part of this, we decided to add on an interaction phase in the design construct contract. So we still divided the superstructure, and I actually engineered the substructure here. And the first phase was a collaboration phase, really based on hourly paid work until the complete design was approved by the authorities. So this was a very good way of collaborating. We were able to work together and everybody has their background and experience. So this was a very good way to get the best result. And after the design was approved, then the price was set and it was turned into a standard turnkey contract. But of course, the client has to be taking more of the risk in this phase. But this is the only way to get innovation. Somebody has to push this forward and it has to be the client. So it's very ideal for learning. Finally, we did struggle a bit with the rules when we all started. I mentioned back in 2014, we really had not much to look at. We had the Dutch CUR 96 version, and first in 2019 we got the English version. But based on this process, the newest version of the handbooks now really have written, this is in Norwegian, but we have opened for using any of these standards, both the English version CUR 96, we have the Norwegian DNV rules. For part of these, we did comparison, actually both in early stage and later in detailed design, between the two standards, and they are pretty much similar. And from this, I guess I want to give the word over to FiReCo, who will tell a little bit more how they actually engineer based on these rules. And just to answer my first question, why to use FRP, I would rather say why not, because it ticks all the boxes. So thank you.
Let me see, I have to do a bit of a sharing here. Yeah. I'm not sure I'm able to die. And this one.
It shows now in the picture.
It shows. Okay. Yes, thank you. My name is Alf Jensen. I am the CEO of FiReCo in with structural engineering for this bridge. I talk a little bit about the regulatory framework and design of composites. So switch to the next. Our company was founded 30 years ago, and our core business is engineering and consultancy within large composite structures like ships, boats, and offshore structures, but also in the recent years, some bridges. So I could look at our homepage to see more of what we are doing. The bridges we have done, in 2003, we had the 56-meter movable Fredrikstad Bridge. It was the first large movable composite bridge in Europe. And in 2002, we had a pedestrian bridge along with a road bridge. It was 9-10 meters elements that was lifted in place. Here is also a railroad going underneath the bridge, so it was very important to have a prefabricated solution. And it's the same for the Paradise Bridge. It's the city train is passing underneath, so we need something above. And also, we could not stop the city train for many weeks, so they needed a prefabricated solution for this location as well. So to the rules for FFP composites in Europe, of course it's the Euro codes, and it's of course for the actions and the structural design, and all of this is standard Euro codes. And as you know, there is standard codes for steel, concrete, aluminum, wood, etc. But we still haven't got to the composite code, but it's under trial. So it's now got a number. It's 19101, and it will be probably in line with the rest in 2005, 2006, 26, 25, 26. So then we finally have a complete Euro code set also for composites. In Norway, we have a handbook, the N400, which is giving the Norwegian special rules and how to do this within the Norwegian laws. And as Stian told you, they opened for using other standards when they are relevant and applicable. So we have used the Cure 96, and of course, since we're working with boats, we know the DNV standards, both for the offshore, the C501, and for the high-speed light craft, which is the shipper rules from DNV. And the high-speed light craft has had composites since 1985. 85, yeah. So a lot of composite vessels has been designed with this standard. So it's a good and well worked through standard for composites. So to the Paradise. Paradise Bridge is stated as a new and groundbreaking design, and when looking into the Euro codes, you end up with in the Annex B, you see that we end up with a consequence class 3, reliability class 3, and this implies the guidance of guidance level will be 3, and we have a full third part verification of the design, and that's that could be a challenging, and I will go through some of the challenges when you end up in this regime. Because in our case, we ended up with an 18 months process with the government, with a lot of back and forth in order to get all the control points in place. Some of this process was due to our lack of the knowledge in using the Euro codes, since we come from the shipbuilding industry. So we are more used to DNV standards and class societies than the Eurocodes. But it also was a lack of experience in composite materials from the third-party surveyors. They didn't have the same experience as us on composites. So that was also some misunderstanding and a lot of back and forth to clarify that. And since we use the Cure 96 and the DNV standards, we have to convince them of that they gave the same reliability level and safety level as for the Eurocodes. So there are some inconsistencies in the Eurocode library when you come with the composite standard, and that I think you will also meet when you use the new Eurocode for composites. It doesn't really fit perfectly at the moment. So I've given some points here which you should be aware of when you start making the basis of design for composite bridges in the Eurocode environment. I will not go through them in detail, just give you some points so that you can have them in mind when you start your own processes. Typical for thermal loads, there are typical deck types in the Eurocode. This is for loads, not for composites. So it's the same rules for all type of bridges. And here there is a lack of, there's no composite deck. The composite deck is a steel concrete deck, not a fiber composite deck. So here there is something missing that should be included. Also with terminal loads, this table in the Eurocodes needs to be rewritten. You need some extra input on composites, or it should be a link to the new composite standard where you can find some standard values for what's asked for in this table. And also we have something that's a bit tricky. In the bridge load classes, the EQU, there is a load case saying that you should use a gravity of 0.9 and a wind factor 1.6. For us, this gives an upward loads on the bearings, and in the Norwegian regulatory handbook N400, it's not allowed to have upward loads on a bridge. So then they forced us to deal with a 50% increase in ballast. And of course, this is just makes no sense. First, you choose a lightweight structure, and then you have to fill 20 tons of concrete on it in order to keep it down. So there are some regulatory issues that could be very difficult to convince to the owners. And of course, we try to convince them that in a truss work and a CFD analysis, you never get very high lifting forces. But they couldn't allow us to use the CFD analysis as documentations because they only used the formulas in the Eurocodes. So here also they need some adaptations to a lightweight structure when it comes to the bridge rules in the Eurocodes. And also there's on the comfort criteria, to look at eigenfrequencies, there should be done some extra work on finding better system and better classes for the eigenfrequency system. So the lessons learned for us is that with the new Eurocode standard, it is applicable with the Eurocodes. You can design a composite bridge with this standard. But you will face not a frictionless process when you're dealing with the rest of the codes. And we recommend and highly recommend to include the Cure 96 and the DNV standards as the basis standards in your IEP and in the basis of design, because then you can use them to fill some gaps and also to add more arguments where you need to convince the owners that you need to make assumptions compared to the rules. And finally, the composite community in Europe, we need to cooperate and collect experience from different bridge projects so that we can show that the Eurocodes is reliable and is applicable, and in a way that we need, let's say, a recommended practice for composite bridges. Because it takes time to change the Eurocode text. So you need some kind of a recommended practice in the beginning. And it's also important when you try to convince and start to sell composite structures to the conservative market and to low risk taking owners, you need empirical data and you need successful bridge project stories. So by that, I send the words to Claes, who did the manufacturing of the bridge.
Okay, thank you, Alf. Let's see, like this. Okay, I'm Claes Olsen. I'm the VP of Civil Engineering in CSUB. And I've called this little presentation Introducing Composites in a Conservative Market Sector. Some few words about CSUB. Founded in 1995, we are now about 250 employees. Revenue last year was 370 million NOK, so that would be around 35 million euros. We have been ISO certified since 2005. Head office in Norway, with also a factory here in Norway and one in Lithuania. Our mission is to reduce cost and the environmental footprint through smarter solutions in FRP. Introducing composites in conservative markets, we know a little bit about that after having first worked towards the offshore industry, mainly with protection and support solutions. We have also a good presence in the aquaculture industry with fish tanks, roofs, process units, bridges, and last but not the least in the civil industry, where we focus on bridges, underpasses, and we have even made the first FRP swimming pool floating in the world here in our hometown. As you have heard, the Paradise Bridge was just installed, and we built that bridge at our factory in Arendal. And here you can see the installed bridge on the first picture to the left. To the right, you see the bridge coming out of production facilities ready for shipment. It was lifted on a boat and then transported to Bergen for further road transportation. And we are all excited about the nomination for the EEC World Innovation Award. I think it's January 13th that will be announced. So introducing composites, we think is a challenge worth tackling. We've had success in doing that, so we can encourage others to try to do the same. Conservative markets often resist change, preferring tested and familiar materials. However, composites offer undeniable advantages such as lightweight, durability, corrosion resistance, and sustainability. So the goal of this presentation is to explore some of the challenges and solutions for entry into conservative markets, showcase some strategies for building trust and encourage adoption, and we hope to inspire collaboration across the composite industry. As with everything else in the world, it's important to understand the market that you are in or trying to get in. And we all know some of these things, they go without saying, but there's a clear preference for proven materials, steel or concrete, of course, when it comes to bridges. Because you have well-established methodologies, you have the same players, they have their ways of working. It's hard to do a step change in what you do on a regular basis. There is also heavy reliance on long-term performance data. So even if you have documented performance in other markets, other industries, it's not automatically adopted in other industries. If you look at some of the trends in the industry that help us, there is a demand for more sustainable solutions to reduce the carbon footprint, and an increased focus on making things last and also reduce maintenance. So in here lies the opportunities as we see them for composites. Cost, reduced life cycle cost, sustainability, reduced life cycle carbon footprint, and the performance, that we have superior strength to weight ratio and durability even in rough working conditions. We've done benchmarking for some of our main products, comparing the carbon footprint with steel and concrete, and we see that in very many cases FRP come out in a very favorable way. Then when we build things, we have to focus on quality. Some of the success factors are build consistent quality at scale. Digitalization in all phases. FRP industry 30 years ago was a lot of handwork, manual labor. We now see a total different industrialization of the process, using 3D tools for modeling, strength analysis, CFD analysis, and following 3D modeling into the drawings all the way through fabrication. It's also important to balance material selection with what kind of requirements the client has for durability and performance. It's important to continuously learn. We are still a young industry, and to have like best practices, as Alf talked about, would be very good for the industry, and at least you have to do it in-house. Proper systems for quality control and documentation, very important. So key takeaway from this: align manufacturing methods with the market expectations to build trust and enable wider adoption. So market penetration, it takes time. You have to educate the whole industry. You can do that by physical meetings, workshops, webinars to showcase the benefits. Demonstration can be quite helpful. Build small-scale pilots, build special critical components where clients may be in doubt, and enter into partnerships with industry leaders or early adopters to drive credibility. Then, of course, you have the cost, the return on investment argument, and it's important to emphasize on the life cycle savings. The reduced weight will reduce the overall handling and installation cost. Maintenance cost will be reduced by 50% or more. And as an example, we have shown the the Fredrikstad Bridge that Alf talked about, where the maintenance during the first 20 years of operation has basically been washing. And of course, the extended durability even in harsh conditions. So for a success story, I think we could show several, but what the bottom line is that you have to find like the launch product when you go into a new market. And some of the drivers will be either related to cost, that in most markets that is still the most important. And of course, increase in design life, for example, components subject to corrosion, wear, or other reasons, and increase in performance, that you make something that is better, it's opening new ways of transportation, installation. You need one or more of these drivers for your launch product. And of course, once you have convinced the client that this is the way to go, you need a combined effort to bring all the stakeholders on board. Start with the end users, the engineering company, the contracting company, the third-party verification entity, and not at least the authorities. And what we have seen is that once you get acceptance for one product in an industry, it's a lot easier to build on that and launch other products. Maybe not as with the same advantages as the launch product, but still you are in the game, and you have gained the confidence that is needed. So what do we think is next for composites? If you look at the emerging trends, I just found this from Lux Research showing the market size of composites. It's very encouraging for every one of us working with composites. There is a growth, and the growth is expected to continue. There's also interesting initiatives on bio-based and recycled composites, bio-based resins, that we hope will be successful in order to bring the environmental footprint further down as we move forward. So our market prediction is that composites will steadily be adopted in industries like construction, energy, and transportation. We see the regulatory framework is following, for example, with the new EuroCode being implemented. And there's the level of competence with engineering companies, architects, construction companies, etc., is slowly increasing. But there is, of course, room for improvement in that respect. So call to action, we still see a big advantage if the industry as such can cooperate in order to accelerate innovation and adoption. So just the key takeaways: composite structures, they have a lot of benefits: lightweight, durability, sustainability. Path to market, invest in manufacturing quality. There's no room for failure. We have to know what we do in the manufacturing. Navigate regulations, early involvement with regulators That's our best advice. Educate customers and find your launch product. So call to action, together the industry can transform even conservative markets and meet the challenges of tomorrow. Yeah. Thank you. I guess I then hand the word back to Vidar.
Yes, thank you very much. I can see that we're running a bit late, but I'm going to finish off with the last 4 minutes here, trying to look at it from a bit of a different perspective, looking at as a composite industry as a whole. Do you see my screen now? Yeah. And we switch there.
Okay.
Yes.
Yes.
Yes. Thank you very much. Then I'm going to take the more organizational perspective and see what could and should be done here. And we've seen the current status. We do have bridges and we do have the technical solutions to make more bridges. But the current status is also that the construction industry needs more knowledge and experience. And the same goes for the authorities that are approving the bridges. So my conclusion is that if we address those challenges on the right-hand side, there can be built a lot more bridges. So hence we have a market potential. And we're going to look a bit more into these two on the right-hand side and look at the reason why there are not more composite bridges built at the moment, because I think we should see more. And I think from both sides here, the reason stems from uncertainties. And the construction sector, they do have uncertainties about how to design with composites, the performance, the circularity, compatibility with other materials and solutions that they are using, and costs. They lack the knowledge and they do lack the confidence. Simply put, they are uncertain about how, when, and why composites should be used, and uncertain about how to know that it is safe. So from my point of view, to get rid of those uncertainties, to make composites a standard choice, we need to let data from the existing projects convince the regulators and the construction companies that someone else has actually already taken the risk for them, and that it's now proven that composites are safe in bridges and that we can approve new bridges faster and smoother. And our solution is the European Composite Bridge database, collecting data across Europe, both qualitative and quantitative data about composite bridges. And the target groups for a database like this are several. The information gathered in the database will, of course, be beneficial for engineers and construction companies. But what I maybe consider the most valuable is the synthesized information extracted from the database that we can convey to the decision makers that we have been talking about earlier during the other 3 presentations. And then I mean decision makers both in terms of regulations and approvals, but also in terms of procurement. As we've seen today, tenders tend to be material and solution focused instead of being based on functionality. And we have to change that. If a tender specifies a concrete bridge with steel rebars, we don't even get to enter the pitch before we've lost. So the ones making the tenders, they need to know about the potential of composites. And here we all have to make a joint effort, reaching as many as possible all across Europe. And the database will be the data you're using as your foundation for your arguments and persuasion. And I'm going to quickly now just show you 4 examples that we have used in the development of this database and what kind of information we are gathering and would like to gather more of. And I'm just going to scroll through it here sideways. we will start with information about the bridge itself, who has built it, who has approved it, who has engineered it, then going over to the bridge itself, saying a bit about what kind of bridge, what composite materials are used, how it was made, and then we get into the engineering metrics that are crucial for the approval. And we have to gather this for a lot more bridges to get this data background that we need for the processes to go more smooth. And we also want to collect the qualitative data, but we haven't yet managed that, but we're going to do that with the existing examples as well. And we do think that the industry will contribute with this, because we do think that they will see the benefit of the transparency, the benefit of the joint data, creating enough data to educate both the construction industry and the authorities who are approving these things. But the question is, how do we go from 4 examples to a full database? And this is where you come in. We need you who are attending here to either relay the information, or even better, put us in contact with anyone building composite bridges today. Then we need the composite industry in Europe to unite around the database and to start use the data when we publish it. And we need to communicate both the data and what the data implies. After this webinar, or most likely early in January, I'll send out a one-pager and a link to a form where you can fill in data for this database. If you're an organization, I need you to send this to your members, encourage them, and remind them over and over again to fill in data. If you're building bridges, I need you to fill in data in this database, because it's only if we manage to gather enough data across all of Europe that this will have a meaning. But then it will definitely add a lot to each one of you's process with authorities and the construction sector. So then we can bridge the gap with composites. Thank you very much. Then we will open for questions, I think, Rafael, or are we running so late that we're I think you're muted, Rafael.
Sorry, I did say thank you for all of your presentations, which shows the reason to choose composite in the bridges. That was obvious, and also sometimes the lack of regulation to help the people. But we see very clearly the value again of the composite. I was interested to also listen on the cost advantage, because sometimes people are not. It's not the obvious one. The LCA advantage as well, and also your last point, Vidar. I think to collect the data, and because we need to prove records, and it's in general when we want to demonstrate the advantage of the composite in different applications, we need to have those live examples. And with the document you were sharing, I think it's a very good start, and that's to collect it. That's so at EuCIA, we of course support these initiatives. And then I leave, yes, we have a few minutes for Q&A, and probably we will need to have another seminar to follow up this first one, I guess. That's also go ahead. Any questions? There is comments on the chat, but okay, Giorgio. You're on mute.
Hello to all. Just a note, we are composite recyclers. We do mechanical recyclers. One interesting thing is that we are nearly, I think, once every couple of weeks, have a request for recycling or processing of laminated wood structure like small bridges and so on. The real concurrent for composite is the laminated wood. Laminated wood is much less, have a very short life, particularly in marine environment, and is something that really, even if it's wood, it's something that really is not recyclable. So I think that we should add to the database of the composite bridges that are, I think, that are the best possible option. Also, a database of or the alternatives with the real cost, because as it was shown, it's always easy to make the things as it was ever done, but in reality the real costs are absolutely underestimated on particularly on wood and also in metal structure. Thanks.
Wants to comments on Giorgio input? Yeah. So we have I take just a question on the chat. Is the Euroclass EN 13511 as a fire smart recognition?
Eric, Elizabeth has a question. Sorry to interrupt.
Yeah, but I was just taking before that. I was just taking the question on the chat, which, and then we go to Elizabeth, of course. So I don't know if you see the question on the chat, if someone is able to answer to that one. Okay, that was the Euroclass.
Can you repeat the question, please? I am looking for it.
The question is the Euroclass EN 13511 as a fire smoke recommendation, a requirement for you, or is it systematic?
Alf, do you have a good answer for that?
We haven't looked too much into that one, but it could be a question. But we use since you're allowed to use wooden bridges, you can use composites. So, and it's not easy to set them on fire. So we have never used any fire restrictions on the bridges so far. Not. And I don't know that one actually. That one in particular, I haven't read it. So, but I can look it up in one of my colleagues who is the fire experts, and he's probably seen it before. So yeah.
Thanks.
Regarding bridges, fire is different because we are in the outdoor environment. So usually it's about safe evacuation, and then of course the length of the bridge is usually allowing very quick evacuation, and then it's important to verify that support services like ambulances or fire brigade can access the site. But those load cases are much lower than normal use. So in general, fire is more approached in from that perspective, and not from the from a standard no test, additional tests are required. But of course, in general, the fire response of FRPs is quite low if you use the normal configurations and the high fiber content. Yes.
Thank you.
I had an additional point, but I'm not sure it's my turn yet.
Yeah. Thank you. You were first before Eric. Then. Okay.
Thank you.
So go ahead.
Thank you. Yes, I wanted to strongly support the appeal for data and a database, and I think it's important for acceptance to grow our market, to demonstrate the quality of our products. We should be able to demonstrate that the longevity is actually real and the deterioration is low, and that it's a big market with a lot of suppliers and a lot of demonstrated applications, but also we are starting 2 important documents in the coming year from the European working groups working on the formalization of the TS 19101. One is an execution document where we work on the bridging the gap that Alf was indicating in the codes towards the realization of the structure and quality control. And the other one is a new effort on calibration of factors, also on temperature models, and not just for what are the temperatures that we have to design for, but also because they have impact on the design factors that we use in the design. And there is a lot of data out there, but it's not collected. It's not centrally located. So I strongly appeal to everyone who has test data on a material level, on a component level, or on a product level to please provide this data, share it with the community, but also share it to the working group working on this calibration of the factors. This can be done through me or through Alf, I think, but please reach out and provide this data, because the quicker we can get those factors calibrated, we can make them more precise, less conservative, and achieve still good reliability. So please, please reach out to us and provide us with those data and facts.
Okay, Eric.
Yes, I would like to react to the comment or the question on the 13501 for fire performance. So on the bridges, what Lisbeth was saying, that it's the structural performance that needs to remain intact to allow the bridge to be evacuated. That is the key thing, and that is not covered in the 13501. The 13501 is a reaction to fire for a material standard. And the main test in that standard is a room corner test. So basically, it's more about the materials to be used in buildings and how they react to fire than the resistance to fire of a structure like a bridge. So I would think that the Euro classes, as they are defined in the 13501, I don't think they're going to be applicable for bridges, but that's my own opinion.
Yeah, thanks a lot for this precise answer. We are just running about 4 minutes late, so if there is some additional questions to group and the experts, you can continue to use the chat here even after the meeting. So I leave it to Vidar maybe for the conclusion.
Yeah, thank you, Rafael. I just want to thank everyone for joining this webinar. It's a topic we're working a lot with in Norway now, and we also see the importance of the joint effort across Europe. So thank you, Rafael, for letting us co-host this webinar through EuCIA. And yeah, I don't really have much more to say than have a great day.
That's perfect. Thank you all for your participation. Thank you.